Okay, so now you can see my presentation, right? The screen with the Enr.
Yeah.
Okay, good. Okay, so first of all, thank you very much. I want to show you who we are. So we are Enr, so we are doing energy efficiency in the buildings in the hot water area with the two systems. The first system is energy GCC with the thermodynamics solar panels, and astral cool. This is an air to water heat pump. Okay, so the first technology is thermodynamic. Okay, that's as we are working in the last months regarding of the SAE University. So you can see the panels are black made of aluminum and just weight 8 kilos. Okay, because we are, you can see the system, the panels are as a standard panels, and we absorbing the temperature surrounding all that have with the environment. If it's okay in the morning or the night, we absorbing the temperature surrounding and produce hot water for the system, for the building. So the ability of the water is 24/7. Okay, so when we replace electrical calorifiers now in terms of the retrofit, so when we do the retrofit, so we can replace electrical calorifiers or boilers, the savings is around 80, 85, and 90, 95%, depends of how big is the building, okay? So this technology, it comes from Portugal, and we are the master distributors here in the GCC. So when we come with the project, so we design the system accordingly of the demand of the hot water. So and based on the different parameters, we give you the solution. It's a tailor-made, okay? And then we bring the solution from Portugal, and we do the installation, we do the commissioning, and we do the maintenance of the system, okay? So here since 2016, so we are around 650 projects in the entire region, okay? So I will explain to you more in details in the coming slides. So here is a typical question they always come in my presentation. What is it for? Because people thinking, solar panels, always they say electricity, you know, like a PV. So I will explain to you what is the difference. So I will, why I want to start this solution, I want to implement this solution in my building. So what are the benefits? I will explain to you all how you can have this OPEX, the same OPEX or savings regarding of the operation, and as well for the sustainability, carbon footprint, and how does it work in the UAE. Because we live in very particular environments when we have thunderstorms, salty environment that is related for the corrosion, or what about in the summer when the temperature rise around 50, 53 degrees, and sometimes 60, you know, in August. So what is the behavior of the system in this kind of environment? So everything I will explain to you in the coming slides. So before to start, just have a look at the traditional panels. So the main problem of them is overheating, as I mentioned, in summer, especially in the summer, and comes as well with the thunderstorm, salty environment. All of the camps get the damage to traditional panels. So corrosion is the main problem, as you see. Regarding of the warranty, is regarding 1 year. The good project, good system comes to about 2 years. And as well, if you don't clean the panels, start to get them damaged, reduce the performance, and always running with electrical heaters, okay? So the cost of the cleaning and the running the system, but the maintenance of the traditional system is very high, okay? And as well, most of the buildings, they don't have a space to install this kind of building, this kind of solution, okay? So now I want to show you the difference with the thermodynamic. Okay, so what is it for? It's for domestic hot water. So you can see the standard panels is 2 meters by 0.80 and only weighs 8 kilos. Okay, so this is the average as here as per DIWA. This is the average consumption in the buildings. 20% of water consumption is hot water. Okay, and between 12 or 50% of the electricity consumption when we use electrical calorifiers. But maybe you're thinking, how does it work, this system? So here, this is the main components of the system. Actually, it's a tailor-made, okay? This is, let's say, one set, one unit. So this is the panels, it's 32 to 40, okay? And this is the solar block. We call the solar block, okay? Inside of the solar block, this is the heart of the system, the compressor, the balancing valves, security valves, all of the electronics is here in the solar block. And we have 2 tanks, okay? Each one is around 3,000 liters, but could be 2,000. It's a tailor-made, okay? So inside of these circuits, we have a refrigerant fluid called R407C. Actually, we have a 1A34A. Depends on the power, depends on the thermal power that you need. So we choose one refrigerant or another one. Okay, so the circle starts like here. So here in the solar block, they say this is the first step. The refrigerant goes in liquid state and negative temperature. Negative, it means like minus 55 degrees, minus 60, minus 65, for example. So you will see ice on the bottom of the panel. So from here, our panels start absorbing all the temperature surrounding more than 0 degrees. We absorbing and change the liquids to the vapor. So the vapors come here in the compressor. So the compressor compresses the gas until 28 bars and reach the temperature 75 degrees and go to the second heat exchange. So the normal waters come here for the preheating tank. So we preheat the water. So here is the recirculation line. So here is the building, okay? So the return line. So here we mix the temperature, the water comes for the return line and the cold water. So maybe let's say around 50, 52, 51 degrees and continue the waters come here in the main tank. So from here, the first heat exchange gives the maximum power to the water, so 60 kilowatts or could be 100 kilowatts thermal power, and we reach the 60 degrees because we need to kill a Legionella bacteria as per municipality. This is mandatory, and we always achieve the 60 degrees, okay? So then go directed to the building, okay? So back again to the recirculation line, sorry, the refrigerant line. So we are closed loop, back again to the solar block. Okay, we have expansion valve here, which reduce the temperature, the high temperature and the high pressure who comes for the hydraulic part. We reduce to the negative and goes again to the panel and start again. So we never refill the gas, we never replace the gas. It's just to change the status. Low pressure, low temperature to the high pressure, high temperature, and vice versa. But maybe you're thinking, okay, so what about in the summer or in the winter time, when in the winter, for example, is 5 degrees, let's say in the worst case scenarios, 5 degrees outside in Dubai, when Ras Al Khaimah, so 5 degrees here in the night, so you will always achieve 60 degrees, always. And actually, we have set up the temperature between 55 to 60, or always 60 could be 62, 63. So we always we agree with the engineering. So what is the temperature that we need to achieve? For example, like 60 or 65, 65, 64, but we always the delta T of 5. So we are sure that the healthy operation for the compressor, and as well they set up the temperature for you for the building. Do you have any questions here?
Yes, I have one question regarding this. What is the maximum temperature possible with this one?
Actually, could be, let's say, 65 degrees, but mandatory here in UAE, as per municipality, is 60. So, but we can go to 62, 63, depends on the engineering, depends on the management. That maximum we can go for 65.
Yeah, some case like we need a kitchen maybe 80, 85 degree. So what we'll do for that case?
So in this case, maybe we can see maybe with the heat pump, but 60 with the thermodynamic, no. Maybe the heat pump with we have as many heat pumps that it will be around 80, 85 or 90. So that this is for the kitchen purpose. Or for the laundry, we are not doing, for example. So the laundry, you need a steam. In this case, it's a steam boiler. But only we achieve 65 as per municipality for domestic hot water.
Okay. And what make the major difference between the heat pump and thermodynamic? It's also working on the same principle, right?
Yes, actually, you're right. But here you can see this is our evaporator, our panels.
Yeah.
So, for example, the heat pump, the main issue they have is the dust on the temperatures that come around 45 or 50 degrees in the summer. So when let's say for 50 degrees they start to running that double cycles and so on, and they get the damage or they don't achieve the temperature. But the difference with the thermodynamic or panels or evaporator can be dust, can be higher, they can absorb the temperature, but it's not necessary to clean to run the system. So they are the same. Each one they have the good advantage, but actually thermodynamic is this advantage These are hybrid systems. These are taking advantage of the heat pump and the solar, the collector, the panels with the better COP. So heat, but it's a heat pump with an enhanced system, so with the better advantage than the traditional heat pump.
Okay, and this preheating is mandatory in all the case, or how it is?
Yeah, okay. This is for several reasons. The first one is preheating the water. Here, the temperatures, as I mentioned before, for example, usually the water for the main tank could be around 23 degrees. Okay, and here the return line, let's say, will be 35 or 45 degrees. Okay, this is an example. So here we are sure that we are coming with around 51, 52 degrees. So the remaining waters come here. We are sure that we achieve the 60 degrees as you need, and as well for the terms of the operation. So when the system feels okay, so start take a shower in the morning. Okay, so immediately the water, the system brings the water inside, so it starts to preheating. So let's say for the recovery of the time, you know, it will be around 1 hour and a half or 2 hours, depends on the capacity. Okay, but 2 hours time, it will be full recovery of the time, the system. So the availability of the water is 24/7. So you never feel the lack of the water in the building, because this is the main purpose, to achieve the set point, and as well the operation, reduce the time, you know, the preheating and the availability of the water in the building.
And also we need to provide the emergency power connection, right?
Well, in this case, it's coming from the main tank, okay, as you see here. So here we have the emergency electrical backup. This is an emergency. If something happens, this is very rare, could be happen. So we have an emergency electrical backup here.
Okay, so in that case, we have to consider the initial, I mean, you know, the power requirement, you have to count for that, plus additional the power requirement for the heat pump and the preheating, right?
No.
One time.
No, so the system works with the thermodynamic principles, okay? Right. And then that's why our compressor depends, could be 11 kilowatts, could be 30 kilowatts, or in the double heater exchange is 22 kilowatts. And the thermal power, you have around 60, 100, or 200. So it depends, but the system, as with the thermodynamic principles, that's why the system have savings. So it doesn't make sense. You want a healthy or a better system that starts with electrical heaters. It doesn't make sense. So if you want to have a savings, it's only with the thermodynamic. This emergency electrical heater is an emergency. It's not for the normal or usual operation. So for the operation, it's only with the thermodynamic.
But still the capex will be counted, right? The electrical requirements.
The electrical requirements for run the thermodynamic is the compressor, as I mentioned. Compressor we need could be, you know, we as a tailor-made solution, we have different range. So could be 11, could be 30, or could be 22. Okay. With the double heater exchange. So depends. So you have a different buildings. So in this case, as in the proposal that we share with you, you have the numbers of what is the power absorption for the compressor. So the compressor could be 11, 30, or 22. Depends on what is the need that you need, and as well the tanks. The tanks could be 1,000, 2,000, 3,000, or 4,000. This is a tailor-made. Depends on the space that you have, depends on the capacity that you need. So everything is tailor-made, but for sure that the thermodynamic works with the thermodynamic principle. So that's why you have savings, and you have the 60 degrees. So maybe you ask, okay, how do I know that the 60 degrees comes in the water? So in the line D, who is supplying for the building, and the return line, and as well for the cold water, and all the electronics is here, we have the monitoring system. So now we know what is the temperature goes direct to the building, and every single point we know what is the water and the temperature and the electricity that is running with the compressor. So when in the dashboard it show you, okay, and this I have maybe 2 peaks in the morning, especially for in the military. So you have in the morning and the evening. So when the people get up and take the shower, or when the people come back take a shower before to dinner. So you can see in the dashboard the peaks of the water. You know how is the high demand. So everything is clear, and we are monitoring. So all of the big buildings, has the monitoring system. So with the system, we are in the next slide, I will show you the savings and as well the power and as well as how much they can save. So everything is clear through the monitoring system. So that's why we give an idea. The Radisson Media City that you will see the picture, they have hundreds or 150 dirhams to produce hot water per day. This is 2 towers, big towers, and they're running the system and they have 100 dirhams. So when we're talking about the savings, it's around 87% savings, which is good. And when we're talking about for the carbon footprint, it's kind of the same. It's 85, 80, 88 carbon footprint.
All right. Okay.
Okay. So let's move forward and let's for the other picture. So I will explain two more. So for example, for the villas, we have as well for the villas. So this is a small unit. Okay, but and as well, so one very important thing, when we size the system, it will be for small villas or for the big buildings. So we are considering what is the thermal power that you need. So for us, it's very important to know what is the water demand that you need, what is the fixture unit. So that's why I always ask about for the drawing. So we can see the fixture units, so we can do the ASRE calculation and we see the thermal power. And then we come to the solution. So maybe you need in one building, you need maybe 2 units like this, so for example, or maybe you need 1 unit, but this is as per ASRE calculation because we see the thermal power and the capacity. But maybe you say, but the capacity is 2,000, this is okay for me, but maybe the thermal power is higher. So then we try to do the balance, and then we can give you the solution. The number of the panels and the number, the tanks, the capacity, and the thermal power that you need. It's the same here with the villas, because people say, I need to do the comparison 2,000 with 2,000. No, we need to see what is the thermal power, and then we can give you the solution. Okay, we will know oversize or even or oversize or undersize. Okay. With the 500 liters, for example, for the villas, we have 250, 300, and 500 liters, 1 panel or 2 panels. Okay, so I will share with you more pictures. Okay, so you will understand. Maybe you're thinking about what about for overheating? Okay, but summer is coming. Now we feel it's very hot outside. So what happened with the system? So first of all, we don't have glass, rubbers, or fragile materials inside of the panels. Actually, you can see the picture. So here is the line where the refrigerant entered into the panel, and you can see ice in the bottom of the panel. So when the system starts to working, we start absorbing the temperature, and then they change the liquid to the gas and go directly to the compressor. And even you can see this ice in the summertime. Okay, and we are using this as a positive collateral effect. Depends on the location of the pump rooms. So we can start in the parkings. Maybe we can start in front of the freshen intakes. So we can use the ice to absorb or to create kind of symbiosis of the system. Okay, I will explain to you with a picture so you will understand better. Okay, so maybe you ask about with the corrosion because we live close to the sea. So first of all, our panels are 100% of made of aluminum with post-pressing and other oxidation and marine paint coating. So that's why we can stand in the most exposed places like in the rooftop in the building. Sorry. And then you can see, this is the pictures that I want to show you. This project is at the Radisson Jazz Island in Abu Dhabi. Okay, actually we have the other 3 hotels. This is under Aldar. So Radisson Media City, Radisson Jazz Island, Parking, and Jazz Link is with the thermodynamic. Okay, and this is close to the salty environment. And this is the first project here for us in Dubai, in UAE. In the middle, this is the 4 points in Sheikh Shah Road. And we sell it in the small area, in the terrace, in the 19th floor. Or here, I want to show you how we can reduce the space, reduce the carbon the footprint, in the building, because we can install 1, 2, 3, or 4 lines of the panel. Depends on the system that you need. Okay, as you see, we are tailor-made. Depends on the system, depends on the unit that you have, or depends on the pump room. Okay. flexible installation. So here I want to show you all case studies that I have regarding of the retrofit. Okay, we have staff accommodation, hotels, villas. So let me show you. So here you can see the panels 10 to 90 degrees, horizontal, vertical. So here, for example, this is the staff accommodation from Dubai municipality. So first of all, we replace 36 individual water heaters. First of all, we centralize, and then we install 2 panels out of the sun. Okay, so and as well here, this is the middle of the desert. So depends on the location. Okay, so regarding of the big hotel, big buildings like a hospital, this is the Nad Al Maram Hospital in Abu Dhabi. So first of all, this is a retrofit. So retrofit means that we replace and switch off the diesel boiler and only install the thermodynamic. So when we see the difference or we do the comparison, this is the savings, 86% savings, and they achieve 45,000 dirhams in the first 4 months. Okay, and then regarding of the location of the panels, you can see in the facade, we're using 0 grand space. This is in the service area. So behind the wall, you can see the tanks. 2 tanks connected with the solar block, 2 tanks connected to the solar block and connected in parallel. Okay, if for example, if we want to do any maintenance, so we can clean the system, another system is running, and then again switch off, and then we can run together. Okay. Okay, hotels. Okay, so in hotels we have 2 or 3 different places. So in rooftop, in the basement, with the middle. Okay, so when the palm room is in the rooftop, like at the Radisson Jazz Island in Abu Dhabi. So this is the first project, or first project here in the UAE. Okay, so when we're talking about the retrofit, so we are switch off the synthetic natural gas boiler and installing only thermodynamic, and you can see the savings, 80% savings, and they achieve 50,000 dirhams in the first 4 months. So you can see how the faster they achieve the savings immediately. Okay, and regarding where is the pump, where is the location of the panels, is in the rooftop, and very closest here is the pump room. So here you can see 120 panels and 31 square meters. Okay, so and you can see the eyes in the top of the bottom of the panel is this as eyes, and this picture it was in August. Okay. Well, other kind of location is in the parking area, like the Jumeirah Saadiyat Island Resort in Abu Dhabi. So here, for example, we did the value engineering. How? So first of all, it's in the parking. When there's the parking, we did kind of a source to complete, you know, because of we don't have radiant, we don't have light, but we have a temperature, but we need a flow, airflow, so we should be close to the ramp, you know, very close to the parking area, the exits. Okay, so and here we did the value engineering because here you can see the exhaust of the laundry. It was outside of the building. So instead we waste and get the damage, so we the environment, so we instead inside of the building. So we absorbing all the heat who comes from the exhaust of the laundry, and as well the temperature surrounding, and produce hot water for the entire resort. And here we have one positive collateral effect. As I mentioned to you, that our panels, there's ice on the bottom, okay? So when we absorbing the temperature, so as well we cool down the temperature in the parking. So this is the side effect. So then you can see, and this one panel produces 1 kilowatt of cooling, and here is 200 panels, 200 kilowatts of cooling, okay? And this 260 square meters, okay? Okay, let's talk about for the resorts. In this case, for the villas. Okay, this is Al Antara the Palm. Well, in all of the UAE, and we have one of the issues is electrical load, electricity. Okay, so here, for example, in Antara, they have the issue. In these water villas, they have a high consumption because this is a quite big bath, and the behavior of the people is they fill the water and they take a shower, so the demand of the hot water is very high. So here we replace individual water heaters in all of the villas, and we installed 1 panel or 2 panels. It means 200, 300, or 500 liters. Okay, and in these water villas, we install it in the middle of the rooftop and the ceiling. And here is the panel. So from this project, for this panel, I want to show you that you don't need to clean the panels. It is out of the sun and it's very salty environment. And this is the installation is here, and the tank is here in the bathroom. So this is a good example regarding of the, maybe it's out of the sun, corrosion, and maybe do I need to clean? No, this is the best scenario that I have, because it's a small unit or big unit, the concept of the thermodynamic is the same. Well, and as well, sorry, back again. With an Antara, we have an Antara Casa Sarat, with an Antara Ras Al Khaimah, an Antara World Map, and an Antara Seychelles. We did, you know, the kind of corporate agreement as part of the energy efficiency and sustainability with an Antara, and we are continuing to do. Okay, so now we went to the island, and now we are going to the desert. Okay, so in this case, at the Ritz-Carlton Al Wadi in Ras Al Khaimah. So you can see the area is very in the desert. So they have, for sure, they need to have a measure to have electricity conservation and so on. So in this case, we replace individual water heaters and thermosiphons. So we replace one per villa, one panel or two panels. So this is the two panels with the 500 liters. Okay, 500 liters will give you 1,100 liters per day, and 0.8 kilowatts is the absorption for the electricity for the compressor. Okay. Okay, now let's talking about the Jumeirah. So as you see, this is the close to the Burj Al Arab. Okay, so here we adapted our panels. Here, for example, in this tower, they have the tanks. So we adapted our flange to connect the coils inside and the good condition of the tanks, and we are connected the solar block and 12 panels. So depends on that whether you need, we adapted the system, okay? And we are part of the energy efficiency with the Jumeirah, with all of the villas. Okay, so now as well, I have the hot and cold water system. So from here, this is at the tank, okay, the main tank. So from the main tank, we have two lines. One line with the hot water, with the thermodynamic, with the two panels. So we are reached 60 degrees. Okay, we have our cooler. With our cooler, we can reduce the temperature for 45 degrees. We can go for the 21 degrees, or 20 or 90. So we always avoid the Legionella problems, you know, but how is we can cool down the water. Okay, actually, it's direct connection to the main tank. So we optimize, you know, the energy, because sometimes we find the cool down and heat again the water, and cool down the water is a lot of heat losses. But when we connect our cooler, it's directly to the main tank, and then we are connected to the villa or the staff accommodation. Okay, so now let's go for the special occasions. So in this case, is the Radisson data. Okay, and Radisson data. This is the big hotel. This is actually the first hotel here in the UAE. It was before Intercontinental. In the main building, in the engineering side, the boiler is there because it's very congested. You know, there is no space to bring out the system or install the new system. So in this case, we create a new area to provide the hot water. So in this case, we installed 80 panels and 20 square meters. So we see, you can see there's four levels of the panels. So we create the frame, and here is very good because we install it in front of the cooling towers. So we reduce the temperature and humidity to take to the cooling tower, and the side effect. So we absorb an extra source who comes for the cooling tower, and as well the temperature surrounding, and produce hot water for the building. This is why we are using the positive collateral effect for the cooling part of the panel. But depends on the case by case. We can do like this. Okay. So here in the first 6 operation months, you can see 83%. Okay. With the thanks for the Radisson for this project, we are the winner for the best retrofit in 2020. Okay. So now other Radisson, Radisson Marina. This project. This is the one I want to show you, okay? So the first of all, you can see that there's no space in the rooftop, okay? So here we create an area for our panels. So we create the frame to install 156 panels, and with the 2 solar blocks. Actually, the double heater exchange. So this is 2 tanks connected to solar blocks and 120 panels outside, 28 panels outside. So this is how we do. So depends on the condition of the building. We do the double heater exchange. Actually, this is 22 kilowatts with 100 kilowatts thermal power. And as I tell you before, this is the 100 dirhams they are running for the entire building. Actually, this has 2 towers. Okay. So the next one is, okay, so 4 points. This is in section room. So here the pump room is in the middle, in the 19th floor. So we are retrofit for the 19th floor to the lobby, because this is the building for the hotel. So for the 19th floor to the top, we cannot, because it's at the residential buildings. These are individual water heaters. Okay, so from the 90th floor, you can see that this picture is this picture took from the corner. So from the both sides on the building, you can see that the panels, and the sun is come from here, but you know the side is no sun, but we absorb the temperature. This is the good point. So we can create, depends on the space, we can create like this facade. And this is the other one that I want to show you. This is in Abu Dhabi. This is the Ritz-Carlton now, is work in progress. This is a special location as well. So now, as well, as part of development to see they create a new projects, this is the Master link. Actually, it's under construction. So from the top, you can see the PV solar, okay, who produce electricity for the building. Okay, so how we can help to the PV to reduce the stress? So we install it behind of the PV or panels. So we are absorbing all the temperature for the PV, and then we reduce the stress on itself, so the performance it will be better. Okay, this is under construction. So now I think in the coming year, I think the Mazda, it will be open, so we can have a site visit. For now, I have only the picture, but I want to show you how we can create the symbiosis between all the system, how the flexibility of our panel to produce hot water. For example, here they want to do the net zero building. So this is good because you produce electricity and the system could produce water as well, so it will be almost net zero building. Well, as well, I have another project. This is the National Historical Museum in Abu Dhabi. It's close to the Louvre in Sadia. Okay. And well, private villas. So we come from the big units, and now we're coming for the residential villas. And here, for example, this is very nice. This in the palm here in Dubai. So when we are going downstairs, in the corner, you can see our installation of the panels. So this is good for aesthetical point of view. We can hide the system, and it's good. And as well, I have other pictures for an antenna. You can see in the corner. Here is our panel. Maybe because it's a lot of, you maybe ask about if the sun is not enough. It is okay because we absorb the temperature more than 0 degrees to produce 60. Okay, and as well, we are part of the petrol stations because we help to them to achieve sustainability as part of the COP28. This is a roadmap for the petrol station with an Emirat and as well as NOx. This is our product. It's a tailor-made product, so it depends on what is the capacity of the thermal power we can adapt. Okay, but this is the units. Okay, let's talk about the maintenance. Okay, so it's minimal because first of all, you don't need to clean the panels. This is the main part, and this is our warranty is higher. Actually, the warranty of the panels is 10 years. Minimum expectancy of the panels is around 35 years, and 5 years with the tanks. Okay, and we are doing the maintenance. Actually, it's just 2 times per year. Okay, and of course we will be sure that we kill the Legionella bacteria, and over the maintenance is coming with the monitoring system. With the monitoring system, you know what is the temperature that you achieve, what is the savings, and the daily consumption. Everything it will clear in the dashboard. It said that with the dashboard, it will clear for the engineer, we can, and as well for us, and as well for the owner. So with this dashboard, we know the consumption. We can create the reports will be per month or maybe every 3 months, 6 months, and then we're going to show you what is the saving that they have, what is the value. And if they want to achieve sustainability, so we can show to the dashboard the information because it's very important as part of the LEED certificate, they have the information. So we have the information, it's clear, and we can give them, and they can apply sustainability, any type of certification. With this information that I have are now is 26 hotels, so we know what is the consumption, what is the operation cost. Okay, so when we're talking about the electrical systems, the savings that they have is around 90-92% savings, and when we're talking about the boilers, it's around 80-85%. Okay, This is from all projects here in the UAE because of the information that we have for the monitoring system. And maybe you're talking about, oh, maybe ask about for the payback. Okay, its average is 2 years, could be 2.5 years, depends, or 1 year, depends of where is the project. Maybe it's in Abu Dhabi, in Ras or Dubai. So depends. And the ROI sometimes as well depends on how big is the project, but it's very good ROI. With information system, we can create a report for the carbon footprint. So when do the comparison in the system in the hotels, the reduction for the boiler is around 70, or when the electrical heater is around 83 or 90%, depends. With information, you can achieve sustainability, as I mentioned before. Okay, so everything is clear and transparent. Actually, with the Emirate station, they apply for Bargil. So because we are as well for the Bargil, the municipality for the Ras Al Khaimah, so the thermodynamic is one of the systems that you can apply as a sustainability. So they apply for all of the Emirate station in the Sharjah and Al Khorfakan is under with us. Okay. Okay, so the benefits here are to bring you the value engineering that we added in the building as part of the energy efficiency retrofit. So we do all of this analysis, and it's good for the building, and as well for they can achieve sustainability, or if you are looking for a solution for the future buildings as part of net zero building. Okay, certification. So we have all certifications around the world, but specific here we have the DCL, Dubai Central Laboratory, certified by the Dubai municipality. Okay, so now we finish with the thermodynamic, and now the heat pump, well, it's air to water heat pump, specifically for the swimming pools. Okay, we have 9 different capacities, and depends on the size of the swimming pool. We can give you the small one or the big one. Okay, it depends on the size of it, and then each one comes with the sensor. So you see what is the temperature that you achieve in the summer, or in the winter, cold or cold water. And this is our reference, our institution that we are working here in the last years. Okay, so as I mentioned before, if you want to have a site visit one of our projects, I will organize for you. Okay, now is your turn. Okay, so tell me if you have any questions. PV is for electricity. Price, the price, I think depends how big is you. Maybe it's a tailor-made. I don't know. The capacity exchanges is different. 2,000, the 3,000, the number of the panels with double heater exchange. I can do the study for example, for a period of the coming year. For example, I can do this, and but for sure, for example, for the boilers, just only thinking about for the cost of the maintenance of the system. Maybe if you're looking for the cost price for one unit, could be cheaper other ones. But if you're thinking about for the long term, the maintenance is very high. So with the thermodynamic, you have less cost, so you have savings in the running the system plus the maintenance. But if you're thinking for the cost, maybe you have high cost and high maintenance. You know, this is the symbiosis or the synergy becomes with the price.
Regarding, do you have installation in Bahrain? I know your team starting here, Bahrain.
Yeah, in Bahrain, we have our team to do the Bahrain. We have in Saudi. Actually, for example, in Saudi, we are doing the Bogo Hotel now. We have Hilton. We are as well part of the Neon, or the big hotels now. They're now developing in Saudi. So we have in Saudi as well to part of the specification, and as well we have for Tarjil, and as well for in Saudi. So we are strong as well in Saudi. But when it comes with as a headquarters here in Dubai, so it means that my boss or we are said that this is the unit that you need, and then our team certify, or check what is the situation over there, and then we come with the solution. So we do a lot of cross-check analysis to bring what is the solution for you. When there's a retrofit, when there's a new system, always there. When there's a new system, because in your project, you need to give us more information. Because when you said regarding of this is the amount of the water, but for example in the clinic, but I need to know how many beds that you need. If you have 2,000, for example, or let's say 300 beds, so then I know that the 300 beds, maybe you need this amount of the water, or if I'm more clear about what is your consumption, and then it's more clear about what is the solution. So back when we decided the system, in some of them it was estimation and based information that we have. But if you have more information, so we more accurate or more specified about the system that you need. Always is based on
right.
You need. If you give me more, I can give you more accurate. I can give you more. More capacity, or maybe you need less panels. So it depends on so many things. But I need to know more about what is the consumption of the water, or for example, how many rooms. So maybe you, as a hotel, for example, I have 300 rooms. I have, for example, bath. I have the fixture unit like this. My consumption is like this. This is occupancy. In the hotel, in the beds for the hospital. Okay, this is the number of the bed. This is my system. This is the water that I need. So with more information, more clear is for us to give you.
All right. Okay. So what you have next is pool heating.
No, that now is I finished the presentation, so now it comes to you to tell me what do you think about it. So I'm here to clarify maybe any question.
Fine, okay, yeah. Actually, yeah, thank you. Like I think you are supporting our team there in Abu Dhabi, and you are in touch with Ahmad and colleague. So this project is fast track. I think it's moving with further development. I think few buildings we completed now, and there is another few buildings about to start. That's good. Actually, you are supporting with all the details, and we are sharing this details with the green building consultant, EcoBuild. So they're familiar. Yeah, I think they're familiar already with your system. So I mean, they're happy, and we achieved few points as part of Isidama.
Yep.
Now we want to focus more onto the Bahrain project. Actually, I know your team here, the Delta and all the people here, and they are I think they're doing some project in Bilad or somewhere in Bahrain.
Yeah, I think. Okay, yeah, Bahrain for sure that we can work if you have. It's not clear. You are working as well now with Bahrain, because I didn't receive the information for Bahrain. If you have the information, we can start to work and support you with all the information that you need. The drawings, maybe you need to add the drawings in your AutoCAD, so we can do this. So full support from us. You can come to me. Ahmad, no, that when he asked me, I immediately sent and as well to propose to bring all of you to here to Dubai to show. It will be around, let's say, 2 hours and a half. In the between of it's 1 hour to Dubai. You can see and back. So I offer everything to clear with you about the system.
Okay, we will try. Of course, we'll try for a visit to see the installation to make sure everything is fine and operators are happy with that one.
Yeah, actually, if you want to talk, let's say, to do more confidence about the system, I can share with you the telephone number of the director of engineering for Anantara, Radisson, or 4 Points, and then you can talk freely with them. That is what I am confident about the system, because the system is working good. And as well, if I have opportunity to meet you, we can show you, through the monitoring system, to see this is data. I cannot share with you. I cannot give you this information, but a little bit I can show you in my laptop about for the monitoring system, because it's a confidential information.
All right, okay.
But I can show you. I can show you. Oh, this is this kind of project. This is the number of the rooms, and this is the savings. Or you can talk directly with them, and to ask all kind of type of information that you need. Be free. I can give you the information for them. And if you have the background of the Saudi, so you can share with me the information so we can start to prepare the proposal and do maybe the study. I think before I sent a study regarding of the air to water and water to water heat pump, and I will share our comments about it as well. It was quite long as well with to say about the eco building.
All right. Okay. Nothing from my side. Hassan, you have some points?
Yeah. So anytime you can come to me. Anytime you need something, I'm here to support you. And as well, tell me anything that you need. I'm here.
Thank you. Thank you very much. Thank you.
I will share with you by email the presentation. So if it's clear for you, if you have any extra questions, you can write me an email. We can reply to you, or maybe we can have a other technical meeting with more specific, more information that maybe you need. So everything is fine. Okay.
Thank you. Thank you.
Okay, so first of all, thank you very much for all of you. Thank you, Afra, for helping me to organize the event, this meeting with your team. I'm more than happy. Very good afternoon.
Thank you. Thank you.
Take care. See you. Bye-bye.